to 6. That's the idea. But if the function is more complicated, how do we find antiderivative? That's a technique of finding antiderivative. Okay? So antiderivative is obtained by antidifferentiation, right? It's a reverse of derivative rule. So what are the derivative rules? Chain rule and product rule, right? So we're going to first take the chain rule, think about reversing it, right? Going backward. And in calculus 2, we're going to understand the idea of this reverse chain rule. And official name is a substitution rule or substitution method. We're going to learn the idea and understand the principle of choosing u. What is this u? What is this u we use in the derivative rule? Chain rule, right? So when you looked at the chain rule, you actually choose u to be something, right? And that process is involved here, slightly more difficult than the chain rule. And understand the formulation of this idea into mathematical form. That's our first task. So, review of the chain rule. Now, many of you can do this without going through u substitution, but I really encourage you to do the chain rule in u substitution here so that you can understand this reverse process clearly. All right. Okay, some is in consciousness. What happened to him? Yes, yes. Let's get back to it. Something you need to learn. All right. Okay. So chain rule. What's our u? That's right. So we're going to write that down rather than, oh, I don't have to write this one down. I don't know how to find derivative there. That's not the point here. So we're going to write that down like that, right? And notice that the symbol I'm using here is equal. So this is a pre-calculus. There's no calculus going on, right? I just rewrote this expression in terms of u to the 7th, right? Next step is calculus. This is going to be ddx. Pay attention to the lower part. I'm differentiating this guy with respect to x, right? And what is the answer? 7 times u to the 6 times, what is it? Du dx. So I'm going to write it in form of du dx rather than just writing 2x there. Du dx. Yes. That's right. You're far ahead. But right now I'm just, differentiating, but that's right. That's involved. So you arrive at here. From here is a pre-calculus, right? You substitute back. Actually, you have to compute this dy dx. That's the calculus part. And then you went ahead and begin to calculate this thing, correct? But I'd like to stay in here and think about in this structure in there, think about how to reverse it, okay? It involves a two-step, and one step here is that remove du dx. Then you left at 7 times u to the 6th, right? Next step you're going to do with that one is that integrate with respect to which variable? Only u. Then what is the antiderivative of this one? You add 6 to 1 to 7, multiply reciprocal of 7 is 1/7, and u to the 7th. And 7 and 7 cancel, right? So this process looks like a very mathematical procedure. We've been learning that. Remove du dx. Dr. Chen, how do you actually do that, right? How do you actually mathematically do that? To go here today, we multiply, right? How do you remove it? Divide it. That's the idea. So this is multiply by its reciprocal. That's the notation I'm going to use. I'm not going to use dx over du. This is du dx reciprocal. So if you multiply reciprocal, du dx is removed. That's a mathematical procedure to accomplish that. And then now you're looking at something only in terms of u. Integrate with respect to u, right? Now you arrive at here, then substitute back what that u was. That is the idea of a substitution method. It involves two steps. What is it? Multiply the reciprocal of du dx and integrate with respect to u. That's it. Now I'm actually going to calculate this one in here and see what that is. 7 times x squared plus 3, 6th power, right? What is du dx? 2x. Now they usually write it like this. Try to get you. Hide whatever that happened to this function. Now in your mind, wipe this one entirely out. Nothing is here. Now you're staring at that one. Your task is what was that function you begin with, right? That's the game we're playing. Is that right? Now in that, this is very straightforward. Once you get used to it, this will be just automatic, mechanical. One thing you have to learn from practice, there's no really straightforward method here, is your choice of u. What should be my u here so that things that I'm about to do works nicely? That requires a little bit of practice on understanding the principle of choosing u and things like that. Okay? What's my u? In practice, they don't tell you what u is. Well, you know the answer, right? U is supposed to be x squared plus 3, right? But without knowing that, how do we detect that? Next one, yes. What was next thing that you have to understand is principle of choosing u. So I wrote down in here, there are two versions, two cases. But talking about two things at one time is just too much. So we'll come back to this general case. Let's think about the simple case first. This is f of x is what we are about to integrate, right? And you know it involves multiplying the reciprocal of du dx. Remember that part? And then integrate with respect to u. So the principle of choosing u is such that first you look at this function in two parts, product of two parts, such that one of the part is multiplied to the reciprocal and becomes c. What is c representing? Constant, right? X's disappear, leaving only constant. If that happens, and if the remaining part is all written in terms of u, then you got the right choice. So it's written in abstract form like that, and we're going to practice, all right? So let me take a look at it here. We're looking at function like this. And you were asked to find the antiderivative of this one, integrate that one, right? And what is the first thing you do? Your choice of u, right? So let's do that. And whether you see this in your mind or not, let's go ahead and choose a typical choice that mimicking that what just happened to our early example. So what is our choice of u? X squared plus 7, right? Your brain told you to do that. Sometimes you do understand, sometimes you don't understand yourself. But you chose x squared plus 7. So how do you know if it's a good choice or not? You test it, right? What is that thing you have to calculate? Du dx. You got to calculate du dx. What is du dx? 2 times x, right? Now, you're looking at this whole thing as an entire one factor. Again, no one tells you to do that. You have to group it so that it makes sense. This is our f1. Is that right? And this is our f2. Now, if you multiply f2 times the reciprocal of du dx, this is just to explain. Usually, you don't have to write down in this much. This f2x is x in here. What is the reciprocal of du dx? 1 over 2x, right? Reciprocal. So do you see that becomes a constant? 1/2? That's what I mean by this one. You look at the function integrand in the two parts. With your choice of u, du dx, the reciprocal of du dx must annihilate the other one. That's the term I'm going to use. Okay? Make sense? Now this is a constant, therefore your choice is good. You move on. Okay, yes. No, you have to multiply the reciprocal, not du dx. Du dx is 2x, right? But you don't multiply du dx, your reciprocal is 1 over 2x. So it's going to cancel, not becoming x squared, yes. F1 and F2? Yeah, look at the whole thing, and you have to group it in your mind. This one is F1 and that one is F2. It's a product of two things, right? Even though if you're looking at x squared, sometimes you have to group it. I'm going to look at it as a product of two things, x times x. This is my F1 and that's my F2, or that's my F1, that's my F2. So it may involve at the beginning stage a little bit of trial and error, but it reduces significantly as you practice more. Okay? So look at it as a product of two things. So that's the second objective. Third one is that, okay, whatever that is, how do we do it quickly and, more consistent and efficient manner? That's the formulation part. So this is a formula. This is one that I really want you to write down and go by this all the time when you're doing this problem. So this is the summary, the substitution method. Write this one down, and we'll be using this one all the time. So this is a summary of everything we have discussed. I mean, almost everything. You're looking at this problem, and you come up with your choice of u equals hx. That's not so straightforward. You have to try it. Once is a good one. And when you write this one down, go ahead and circle this part in here. I care about this one a lot. If that's missing, I'll go mad. And, it's got to be there. That's very important part of the math method. You're integrating with respect to x. At this stage, you're switching to integration with respect to u. Okay, so recognizing this is very important to me. Doing mathematics correctly. So student deliberately missing that one because they're afraid and not writing down this d thing. If it's missing, it's a problem too. So you have to write correct d thing. It's called differential. That's the name I have to use so that I can finish my sentence. All right, now inside there's some cancellation going on. That's why we chose that u and simplifies into something only in terms of u. All right, this is supposed to be simpler than the original one. Then you actually integrate. Then you put back what that u was, the original one. So this part here is multiplying du dx reciprocal part, and is integrating with respect to du is this final bit. Those two things are formulated as a mathematical equation like this, right? So we'll keep it in there. We'll look at examples to use this one correctly in terms of using notation and things like that. All right. So that's the formulation. This is an example part. So we can look at these examples of a chain rule and cheat from there and have an idea about what u should be good for the integral example. Let's do this derivative. It's not integral. So what is your choice of u when you differentiate this one? U is going to be x squared plus 2x plus 1, right? Good. So when you're differentiating it, this is a d dx of 1 over u. Is that correct? No. Or you could write it as a u to the negative 1 so that you can differentiate it easily, right? The power rule. So negative 1 comes down. Is that okay? U to the negative 2. I subtract 1 from the exponent. Then you have to multiply what? What's that? No, that's the integral. This is a derivative rule. This is a chain rule. What do you do in the chain rule? Du dx, right? Du dx. What is du dx? 2x plus 2. Thank you. Now we put it back in there. Negative 1 there. 2x plus 2 belongs to numerator. Denominator, the negative 2. So here's x squared plus 2x plus 11 squared. That's the result, right? That's the derivative. We learned that in session 2. Is that right? Now we're reversing this one. But it looks a lot like this, but it's a slightly different problem. Now we're applying substitution method. Now look at the problem like this. What is the antiderivative of the following problem? X squared plus 2x plus 7 squared dx. Okay? I hope you see the similarity of these two problems. Here you're asked to find the antiderivative. We just differentiated something, right? have a similar structure. Is that right? Denominator quadratic squared. You have a linear in the numerator, right? Okay. From that information, first thing you have to do in the substitution, and underneath it, you write down the choice of your u. Is that right? So, do you know the choice of u? X squared plus 2x plus 7, right? Knowing that, what happened to that example? Maybe that's nice thing will happen. Yes. Got what? This from here to there, or this one itself? Let me hear it first. This one, bracketed part is in question, or going from here to there? Okay, so that one belongs to numerator. This one is the same as 1 over u squared. And negative 1 times 2x plus 2. So that can be all collected in the numerator. Okay, good. Anything else? Okay, back here, next thing you do, you determine whether it's a good choice or not. Okay, how do you determine it's a good choice? That's right. You have to calculate what first, and then determine it's annihilate. du dx, what is du dx? 2x plus 2, right? Okay, so now what do you do with this one? Multiply du dx or the other one? The other one, what is it? Reciprocal is integral. Chain rule, you multiply du dx. Integral, you have to do it opposite. You have to multiply reciprocal, right? What happened if you multiply the reciprocal of that one? Does something cancel out nicely? If I write this one like this, you see it better, right? But before, maybe didn't. Now if you write it like this, oh, I see it. What cancel out? X plus 1 will cancel out as I multiply the reciprocal of that one. All right? So we got an approval. We're going to go to the next part, right? So this one in here. Now integral calculus takes place. These are all differential calculus, right? Now what is most important part? You recognize this d. What's supposed to be here? D what? Du, thank you. So please do not forget that. You write du like this, loud and proud, and I love it. Okay, so here's x plus 1. And, because we already wrote that one in u squared, is that okay if I, at this stage, change it into u squared? Our goal is changing everything in terms of u squared, right? Yeah. So what are we supposed to multiply here? 1 over, right, 2 times x plus 1. Is that right? 2 times x plus 1. That's 2 times x plus 1. Reciprocal of du dx. Du dx is this. Reciprocal would be that. Yes, sorry. Okay. This factor actually has a name. This one is called Jacobian factor. You will learn this one in calculus 3. But it has name. It becomes far-reach geometric object. Right there, this factor we multiply when we switch to x and u, what is it called? Jacobian factor. So I'm going to say that. Multiply Jacobian factor. Do not forget to multiply Jacobian factor. What is Jacobian factor? Reciprocal of du dx. Good? Yeah. Okay. Let's continue. Did you all circle du or color it or something like that? Yes, here's your good partial credit right there. So are you going to cancel something? X plus 1, right? X plus 1 cancel. You're left with what? 2 times u squared. 1 divided by du right there, right? Now you did all that. If there's some x lingering around, go back and fix it. Don't do something creative at that stage. If there's still x in there, you did something wrong. Either your choice of u is incorrect or you did the algebra wrong. Okay? Now, do you see an x in here? No. Then you're good to go. What was the next step? Integrate. Can I pull out 1/2 out there? Yes, constant multiple. And change this one into what form so that you can integrate easily? Exponential form, u to the negative 2 du. So, what's next step? 1/2. You add 1 there, right? So it's negative 1. Is that okay? Add 1 to the exponent, and reciprocal of that exponent, you just change. There's negative 1 there. Good. So it's all together plus c. Negative 1/2 u to the negative 1, so it's x squared plus 2x plus 7, negative 1 plus c. Yes, question. Okay, so the rule is that antiderivative of u to the alpha du is you add 1 to that and always multiply reciprocal of what you see there. And you just added, simplified it, 3 over 2, 5 over 7, multiply reciprocal. That's where they came from. Right. But this exponent you're looking at there without integral. That one, not that one, okay? Yeah, good. So that's that, and then you write it here neatly. 2 divided by putting it back in their denominator, 2x plus 7, and plus c. Final answer, right? Okay, you deserve a break. Okay, so we'll take a break here.